This is an introduction of first order differential equations. In this video I'll go over solving for y using integration. So basically a derivative will be given to you and I'll go over how you can use integration to solve for y. So to start off we have this simple equation, dy over dx equals xy. In other words, the derivative of y equals x times y. So the first step in solving for y is to separate the variables. So what I mean by that is clubbing the x term with the dx and y with dy. So in this case it would look like dy over y equals x dx. I divided both sides by y and then multiplied both sides by dx. So I get dy over y equals x dx. So now that we have all our variables on either side of the equal sign, the next step is to integrate both sides. So as long as you do it to both sides, it's fine. So integral of x dx equals integral of dy by y. So from here, all we need to do is integrate both sides, and that would give us natural log of y, because the integral is like the antiderivative. So what equation, once you take the derivative, would give us this? So the natural log of y would give us 1 over y plus c. So we have natural log of y plus c, because there could be a constant we're unaware of, equals x squared over 2 once we integrate this, plus c. This is just the power rule, x squared over 2. And so since c is any constant, we can club c together on one side. This will make our job easier because this is technically c1 and this is c2. And since they're both constants, if we subtract c2 by c1, then it just gives us one constant. So we can say natural log of y equals x squared over 2 plus c. And that could be c3. I'm not going to write c3. It'll just be c. And so now that we have integrated and got rid of dy and dx, we can now just isolate for y. And so when we do that, we can see that we know that e to the power of natural log of anything is that equation inside the brackets. So in this case it's y. So if we take e to the power of both sides, equals e to the power of x squared over 2 plus c, then here e to the power of ln would be 1, and that would be y equals, and then this. And so usually when we have e to the power of something plus c, e to the power of c is again just a constant. So we can put c out in front like this, c times e to the power of x squared plus 2, as opposed to e to the power of x squared over 2 plus c. We can say c e to the power of x squared over 2. And so we've solved for y. And so this is basically it. We will first separate the variables, make sure they're both on their corresponding side, and then take the integral of both sides, and then integrate, and finally solve for y. But it does get harder, and that's mainly due to the fact of what equation is given to you. So gradually the questions will get harder. For this question, what we can do is first cross multiply x plus 3 times dy equals y plus 2 dx. And so it's not paired up accurately, so we can do some reshuffling and we'll get something like this. 1 over x plus 3 dx, then 1 over y plus 2 dy. And we reshuffled, and now all we need to do is take the integral on both sides. And just like before, the integral of 1 over any equation with a degree of 1 is natural log of that equation. So natural log of y plus 2 plus c. But like I said before, we can put all our plus c's on one side of the equation. So in this case, I'll put it all on the right side. So this is equal to natural log of x plus 3. And if you can't integrate 1 over x plus 3 that easily, you can make a u substitution if that makes it easier for you. You can make u x plus 3, and you get 1 over u, which is natural log of u, and that is natural log of x plus 3, and get plus c. Now, like before, e to the power of L natural log is that equation. So we can take the e to the power on both sides. And we can write c times e to the power of a natural log of x plus 3, because e to the power of c is another constant. So we can write this as well. And from here, e to the power of natural log of any equation is that equation itself. So we can write y plus 2 is equal to c times x plus 3. And since we've integrated and solved partially, we can now isolate y, and we get c times x plus 3 minus 2. And so we've got our original equation of y, and yeah. So again, our first step is to separate the variables. And so, like in the last question, when you see brackets, I would advise to keep inside the brackets. So move the brackets as a whole. So I'll move y squared plus 1 to the left side. That would give us 1 over y squared plus 1 dy equals x squared plus 1 dx. Now we can take the integral of both of these sides, and in this case, working on the left side first, 1 over y squared plus 1 is actually identity. So 1 over y squared plus 1 is actually tangent inverse of y. And so that's not something I can, like, it would take time to understand that. But the main point is there are certain trig identities you need to understand. 1 over y squared plus 1 is the tangent inverse identity. So this would be equal to tangent inverse of y squared plus 1. No. Tangent inverse of y. Yeah. If it was negative 1 over square root of y squared plus 1, it would be cosine inverse. And if it was positive 1 over square root of y squared plus 1, it would be sine inverse. So this is an identity. And on this side, x squared plus 1, we can use power rule, x cubed over 3 plus x. And then plus c. Remember, we had a plus c on this side as well. All we did was subtract it, and we got a new constant, c. And so from here, all we need to do is isolate y. And when you move tangent inverse to the right side, you simply get tangent of x cubed over 3 plus x plus c. And so that is our original equation. So important thing to note, you need to understand the identities before attempting a first order differential equation, because it can pop up 1 over y squared plus 1. You can't use a u substitution, so you would just have to know that identity beforehand. So because I knew that, I wrote tangent inverse of y. So for this question, we can cross multiply. We get y squared dx equals x dx. And this is a pretty straightforward question. We can integrate first, integral sign, and then integrate y cubed over 3 equals x squared over 2. Easy power rule on both sides. Don't forget the plus c. And so now all we need to do is isolate y. Multiply both sides by 3. And now all you need to do is you can cube root both sides to get isolate y. So y equals cube root of, I'll just multiply 3 in, so 3x squared over 2, and 3 times c. I can write 3c, but c is a constant, and so 3c would just be a bigger constant, so I can just keep it as c. And that is the original equation for y. Now this next equation we can first cross multiply, but I think we need to do more. So x dy equals e to the power of y dx. And since it's not matched up, x is not with dx and y is not with dy, we can do a little more reshuffling, and we get 1 over e to the power of y dy equals 1 over x dx. And so from here, 1 over e to the power of y, we can rewrite that as e to the power of negative y. It's a law of exponents. And so if e to the power of negative y dy equals 1 over x dx, we can integrate both sides, and we would get e to the power of negative y, negative e to the power of negative y, because if we differentiate this, we would get e to the power of negative y, plus c equals natural log of x plus c. And so the hardest part here is to isolate y. First, I would transfer the negative sign to the right side. So e to the power of negative y equals negative natural log of x plus c. Actually, it would be minus c, because we had to multiply negative by both of these terms. So e to the power of negative y equals negative natural log of x minus c. And so now the natural log of e is 1, right? No, the natural log of e to the power of negative y would be negative y. Yeah. So if you take the natural log on both sides, you'd get natural log of e to the power of negative y equals natural log of the natural log of x plus, or no, minus c. Yeah. And so natural log of e to the power of negative y, that's just negative y, equals natural log of negative natural log x minus c. And so we transfer the negative sign over and we get y equals to negative natural log of the negative natural log of x minus c. And so that is our equation for y. So a few things to note. It's easy to integrate. I mean, usually it's easy to integrate, but most of the times you'll find it harder to isolate for y. And so it's really important to understand the correlation between natural log and e, because it will make your job much easier if you know these things beforehand. Second thing I would advise you understand before attempting a first order differential equation problem is to understand and memorize the trig identities. So 1 over u squared plus 1, that's tangent inverse, and then sine inverse, and then cosine inverse, and memorize that. And so that would make your problem solving abilities much sharper.